All right, so what are some other reductions that we can make to a block diagram? Well, imagine we have an input u, then we have our usual g, and an output y1. But also, we have an output right here. This just means that it's going this way again. And then we have a y2. So we want to store two values, our y2 and y1. Our y2, of course, is going to be equals to our u. Now, one thing we can do, now of course, this seems pretty pointless at the moment, but you'll see that you'll find it useful, is multiplying by g, and then having two outputs. The y1 didn't change, but the y2 will need some work. We'll need a division, 1 by 1 over g, to get our y2. Now, one other thing that we can do is, of course, moving a block. So, for example, let's say we have two inputs, u1 and u2, and they come together, both plus, and we have our g here. Well, what can we do? Well, we can take our u1 multiplied by g, take our u2 multiplied by g, and then add it together. Of course, we can do this with the minus as well. I'm just not going to show it. And one other thing that we have is our input r into a sum. Here we're going to have a negative feedback loop with our usual g1 here, output y, g2. Okay, we can convert it to something a little more, little different looking. So we have r, and then we have 1 over g2, and then we have g1 times g2, and we get our y. As you can see, it follows a straight line up here. But also, we can just take this, break this into two pieces, and say plus and minus here. And as you can see, this becomes like a easier way to do it. And of course, we have our r divided by g2 immediately. Well, we also know, of course, that this growth is going to be something like r divided by g2, and then times g1, g2 over what divided by 1 plus g1, g2. It's just a different way to break it down. Other reduction, of course, is all these operations are linear. So if we have u1, u2, and we are in these two together, and then we have another input u3, and we're adding it, then we can just move our u3 to earlier. We can say, for example, u1 and u3 right away. I'm gonna say like this. Yeah, doesn't really matter. I can say u2 to be added later on. Now, of course, this works for minus as well, because we know it the order operation doesn't change for these things. We can also move the so-called kickoff point. So, for example, if we have an input or whatever, a signal, and we're breaking it into pieces, and so, for example, here we have our u1, u2. I'm gonna call it y1 and y2. I can make it different and make the y2 get the same data earlier. Doesn't matter how we move it. We can also make it at the same point, really. This doesn't change it. Okay, now time to draw a little dot here for this kind of stuff. So why don't we do a little harder one? Let's say we have a double feedback loop, and both of it are negative. So we have our R, and then we have our first negative feedback over here. Then we have our second negative feedback. So I'm just gonna call this G1, G2, G3. Okay. Then this one will break it over here. Then we have our y. Okay. These are pickoff points. Now the first thing we'll do is analyze the inner one. So we can say that we have a negative feedback loop. So we are gonna have g1 over 1 plus g1 times g2. And so we can rewrite this as our r plus their minus over here. And then we have one single block here, as you can see, makes things easier. G1 over 1 plus G1, G2, the Y, and then a G3 right here. And then we can do the same thing again. We obtain then it's equals to G1, and then 1 plus G1, G2 over 1 plus, and then we have G1, G3 over 1 plus G1, G2. Okay, because of course it will be broken down like this. Right, because that's the top, this one is the top, then we have the bottom G3 right here. Okay, but I just brought it in the denominator. Doesn't matter. And of course we can simplify this. I'm gonna show you step by step. So we leave the top as it is for the moment. And then we have the bottom 1 plus G1, G2, plus G1, G3 divided by 1 plus G1, G2. So these two things simplify, and we end up with G1 over 1 plus G1, G2 plus G1, G3. All right, well, I think this is pretty straightforward for the moment. There's not much to say about this. Of course, you're gonna have found some different stuff around. As long as you remember these things, you can move the pickoff points. So, for example, one example that I like is what if we have this G3 that picks from here and then a G2 that picks from here. As I said, the pickoff points can be moved around, and so we can do this thing here is going to be the same thing as what we just did here. We just moved the pickoff point to make it look better and look probably more presentable to our eye. And that's pretty much it. That's all you need to know about the block diagrams.